This is a brief overview of how to use this handout, Steam Table Process Overview. This is for the steam tables, so it relates to water and the phase of water, so whether we're a liquid, a vapor, or someplace between a liquid and vapor. We can use this chart to find our different properties, our state properties, and what's known as fixing the state. And we can use this table to help us find those values. So for instance, if we're given this first column is your given properties, and you use whatever you're given, then you go down that column to find where you're at. This second column is to test to determine what region of the vapor dome you're in. The third column here, they give you the vapor dome diagram. So what they mean by test to determine the region you're in. If you're in this area of the diagram, anywhere over on this side, then you're a liquid. If you're anywhere in the middle here, then you're in the dome, and that's a two-phase liquid vapor. And if you're anywhere on this side of the dome, then you're in a vapor. So blue is where we have liquid, red is two-phase, and green is a vapor. And you have the critical point, which we can find on table A1 to find the critical temperature and pressure of water. Then anything to the right of that is vapor, and anything to the left of that would be liquid. So again, how do we use this table? Oh, and then lastly, this last column here, where and how to obtain the property. So once you determine where you are in this vapor dome diagram, then you can figure out what tables to use to look up the rest of your properties. So again, the properties that we're considering here, we have temperature, pressure, specific volume, specific internal energy, specific enthalpy, and eventually specific entropy. So we can use this table. If we're given any two of these and we're in the liquid or the vapor, we can just look up and find all the rest of the values on the tables. If we're if we're inside this red dome part, then we need to have three variables, because temperature and pressure are not independent at that point. But let's use the first two columns, first two rows here are given. If we're given pressure and temperature, then we can use these two first rows to look up and find what values we have. So these are for being given pressure and temperature. So these two effectively are given the same things to start with. And you can do use either of these rows to start to find what you're looking for. But the first thing you do here, if you're here in this first column, we want to look up pressure on table A3 or A3E. Again, the difference is A3 is SI units and A3E is US customary or English units. And so we have to first decide what units we have, and then we can pick the table. But we look at table A3 and we're looking up P, and we find Tsat from that table A3, and this would be in the second column of table A3. So we look up, find the pressure we have in column 1, and we go over to the next column. It says temperature, but that is the saturated temperature. And what that means is this temperature, over looking at this diagram, T equals Tsat when we're in the dome there. So that's the saturated temperature and for a given pressure. So then given that saturated temperature, we compare the temperature we have to the saturated temperature, and that's how we decide where we're at in this dome. So again, first of all, if the temperature that I have, that I'm given, that I'm looking up, is less than my saturated temperature, then I have a compressed liquid, and I know I'm here, right here where it says A on this diagram. I'm over here, and then I come to this other table or column over here, and it tells me to go to table A5 or A5E to look up the values for the other properties we have. So in this case, all of these saturated specific volume, specific internal energy, specific enthalpy, or specific entropy. If my values are not on table A5 or A5E, if you can't find them there, then you can approximate them using table A2 or A2E, and you approximate as a saturated liquid. Again, that's the values that have the F, saturated liquid. So you look down the columns VF, UF, HF, and so on, and find those values on table A2. And again, that's only if your values do not appear on table A5. Next, we can, if our temperature is equal to the saturated temperature, then we know we're in a two-phase liquid vapor, and we're someplace in the dome here. We also know that P and that pressure and temperature are not independent. The pressure and temperature are the same all the way through this area, but we can't decide where we are, what specific volume we have. We're somewhere between VF and VG, but we need another independent property to be able to decide where we are in this. We could use X, which is quality. At VF here, quality is 0. I shouldn't write it like that. VF is not equal to 0 there. But at this point, quality X equals 0. And at this point, where VG is, X would equal 1. And we're someplace between there, 0 and 1, when we're in the dome here. Again, this is the VF or UF or and so on point, and this is G. So this is the saturated fluid or liquid, saturated liquid at F, and the saturated gas or saturated vapor at G. Then if we're greater than this, if our saturated temperature is greater than, if our temperature is greater than the saturated temperature, then we're in a superheated vapor. Or likewise, if we're greater than even the critical temperature up here, then we are still in a vapor over here, in a vapor area. And then if we're in a vapor, then we go to table A4 and A4E to look up the rest of our values and find the properties that we don't have yet. Similarly, we can use table A2 to look up temperature, and the second column, we find saturated pressure in the second column of table A2. And similarly, if our pressure is greater than, in this case, our saturated pressure, then we're in a compressed liquid. The pressure volume diagram looks like this, and we would be in right here at A, and again this would be liquid. Anything over here is liquid. And we can then use, again, table A5 to look up our values, or we can approximate as saturated liquid, so VF of T, and so on table A2E. But only do the table A2E if table A5 doesn't include our values. Likewise, here, if our pressure equals our saturated pressure, then we're here in this dome area, and we have the two-phase liquid vapor, and we need one other independent variable to find out where we are in this dome, because they are not independent. So we need another value. And then finally, if we are in, if P is less than the saturated pressure, then we're down here, and we are in a vapor area. So again, what we mean here, so here this would be our pressure, and that line is lower than this line where P equals Psat. And likewise, if we're here, if we're greater than, so our pressure here is greater than the saturated pressure, and then we're a liquid. So we can, if we have other properties that we're given, we're not given both pressure and temperature, then we can use these other columns, and you can see here, if we're given temperature and any of these properties, specific volume, specific internal energy, specific enthalpy, or specific entropy, then we do the same similar way of following this. We look up T on table A2, and then we find, so if we're given the specific volume, then we would look up and find VF and VG, and we would then use those to determine where our given value falls. Is it less than VF? Then we know we're here at A, we're a liquid, and again, if we're a liquid, we would use table A5 or table A2 to approximate the liquid. If we are between VF and VG, then we know we're here in a two-phase liquid vapor, in the two-phase area, and we would use table A2 and use the quality calculation. And I'll show you the quality calculation in just a minute. We'll go through these really quickly, and then we'll look at that. And also here, if we're greater than, then we know we're over here, and we're a vapor at C here, and we would use table A4. So similarly, if we had pressure and those values, then we would look up pressure on table A2, A3, table A3, or A3E, and again we would find F, the saturated liquid specific volume, and the saturated gas or saturated vapor specific volume, and we would find where we were with relationship to that. If we are less than our liquid, our saturated liquid value, then we're here at A. Between them, again, we're in a two-phase here, and if we are in a two-phase, then we need to find the quality calculation to determine where we are, but we would then look things up on table A3, and then if we are greater than the specific volume at a saturated vapor, then we're here at C, and we're a superheated vapor. So this is vapor, and we would use table A4. If we are given temperature and quality, then we would know that you only have quality if you're in the dome here. So you're only in here. There's no other place you would be. Quality means that you are a two-phase and nothing, you're not going to be completely liquid or vapor ever with your given quality. And then we would just use table A2 with quality, and we can also use the calculations below. And the same thing if we're given pressure and quality, then we definitely are in a two-phase liquid vapor mixture. We're in here in the dome. We're not outside of the dome, even though I went outside the lines there. And then you would use table A3 with the quality calculation. So quality, again, is just the value, that where you are in the dome here. So if we look at this and we say, this is the point F and this is G. So this is saturated liquid. This whole line here, this is saturated liquid all the way up to the critical point. And then on this other side of this, this is saturated vapor, all the way on that line. But so for a given P here, and we, this line going across, and we're given P on our diagram here, then we're on this line somewhere. And if we're given quality, or we know we're a two-phase liquid vapor, we know we're between F and G, those points on here. We're between saturated liquid and we're between saturated gas or saturated vapor. So here at saturated liquid, my quality is 0, and here at saturated vapor, my quality is 1. And in between there, we're just some ratio between there. So we're either, if we're halfway, then we're at quality of 0.5. If we're 3/4 of the way, then across the dome there, then we're at a quality of 0.75. So this is just a ratio of those values, and they give you formulas for those. So if you're given given a value of specific volume here, then we know that we can use this formula. So we have the